stupid things like this. And because your compiler is going to fix crap anyway. So, and I highly doubt your entire code base is going to revolve around you optimizing the isTarget off-screen function, which gets called 5 times per frame. And just because of, you know, removing branches in the assembly, that's just not going to happen. Yeah, that's one of the things that in college, it was really funny. People would argue about, like, that's 200,000 more operations per tick than, you know, this other optimized way of doing it. And it was just like, dude, that's nothing. You're arguing over a fucking zero. It takes a hell of a lot longer for that damn database call you just added. And those 4 CPU cycles are also not gonna fucking matter because, you know, processors do things. It's probably going to optimize it so that it does that crap anyway and compares it at the end. So it doesn't matter. Yeah, forget everything you've learned. That's like the ArenaNet thing was, do you know how a computer works? That's all we care about. Everything else you're going to learn on the job here. Target is off the bottom. Target's off the bottom of the screen. That's total shit. It's completely not off the bottom of the screen. Like, if target.z is less than position z minus half height is 1500. Target z is 149. And the player proxy actor is at 5000. So it's because this our offset is going to be wrong, right? So if we have an angle of 2 degrees, the sine of 2.5 degrees is this value. The magnitude of our camera's distance is what? (7242), and kind of the triangle is that distance and then that distance. So I've got to have something wrong here with what I'm doing. Because like if we have a 2.6 degree thing for what we're looking down, and somehow this is looking down a lot farther than we would think. Because if we're at the same level as this guy, we're at 2,000. So half of our width would be 1,500. And for our correction, it's going to be 0.043 times 17. So it's like at 1,800. So something's going on here where our downward angle is not, it's not quite what we're actually using. So the question would be, is our downward angle actually what we're doing? Or are we doing something like it's actually downward angle times 2, or why are we even looking at this at all? Like, shouldn't we just be looking at our player proxy actor and looking at the rotation from it? Yeah, so we should actually not be using the downward angle. We should be using use the rotation. Yeah, that's supposed to be the half height. And we should be getting get actor transform, get rotation. It's what? Yaw is the rotation around the z-axis. It's what? Pitch, yaw, roll. So we should not be using any of this crap. We should be using this. Our position, our location is negative. So what's going on here is we need to be taking the absolute value of this guy. Now the question is the yaw and all this other stuff in radians or is it in degrees? Because it might be drawing it in terms of degrees inside of the editor, but then it's in radians. I'll have to put a breakpoint on it. Aren't all floats signed though? Yeah, they're signed. Just the camera X was actually we were like rotating ourselves in the wrong direction. Ah, it's pitch. We need pitch, not yaw. Probably also need an object size passed in for targets off screen. Target's still off the bottom. going to change all the signs around for everything. Math stuff is just math stuff. That's one of the things I think is pretty funny. Everybody was like, oh man, programmers they love math. They're so good at math. We're like, no, man, I write programs so I don't have to fucking do math. I do it once and I never do it again. That's how it works. Especially game programmers. It's true. So we're calculating the height of this guy as being, because it's probably that. So let's see. What must be wrong is our camera width and height must be wrong. Like, that's just gotta be what's going on here. Is this get camera height is just gotta be wrong. So how are we actually doing it? Our height is going to be our X location is going to be our distance, but that's not actually going to be our distance, right? Like, our distance is different than that. And so if our field of view is what, 45 degrees, so we got, 22.5 for our half, so the issue is going to be that our camera width and camera height here for these guys are just wrong now because we have a downward angle on this thing. So it's that fundamentally we have issues with this sort of thing. So what is our height going to be? If we're looking here and our height was this, it's actually more complicated because we're looking down. It's not like just rotating around this thing. We actually, because we are looking down, need to add in the distance. So our height is actually going to increase by the distance that we're looking downward or something like that. So yeah, our camera height is wrong here. Our width calculation is correct. Because we don't have any other things. Yeah, use the check if it's on screen. I mean, I'm gonna do this math here, so you can do it. Alright, so this is wrong because I need to add in the other stuff. So the height of the camera is going to be the projection of this thing onto this location. But we're pretty much almost there. We just need it just needs to be taller. So I think it's just the same calculation. I think it's just going to be the height is going to be plus equals the transform times that distance. I think that's all we have to do. So let's try that. So as this thing looks down, its height in the world is going to go to infinity. So our distance is going to be well, let's see how it works. It doesn't have to be perfect, it just has to work better. It's basically, I'm using the wrong math for this. Like, the math that was started with using was when we were facing directly at the thing and we had no downward angle in the camera, and then that got changed, and then all the rest of the math didn't get updated. Because we should have been actually using the matrices and the actual screen space, like put it in screen space and then translate that back into real world units in some ways. You know, do the inverse. Just using the wrong math to begin with. Should have done it the real way. Just from the very beginning, should have just grabbed the camera matrix and used projection equation crap on it. It's off to the right? What the fuck? This is one of those things where maybe I should have just rewritten the whole fucking thing from scratch. You've been up for 23 hours? Yeah, might want to go get some sleep then. Come on, copy the... Come on, Visual Studio. Stop freaking out. Alright, so the difference is... $2,841. Can this please fucking leave? So that's 2,841. So that's like 3,000. So if that's 3,000, then our total width is going to be like 6,000 or something like that. So our camera width and heights are just wrong. Just flat out fucking wrong for this thing. Alright, this is just all screwed up. I'll be right back. So where the hell did these camera width and height calculations come from? Because it should be, if we are looking at something and we have the aspect ratio, we've got the width is going to be, I want to take the sine of this thing. Yeah, god damn it, it's more this fucking, this crap here with this tangent, which is wrong. So it's just degrees to radians with the field of view times the distance is going to be the height. So like this tangent shit just needs to go. So field of view is going to be the width. Is like our width and height just totally screwed here? Like they're the wrong numbers? We just got our width and height backwards, where one of them is, like I just got the aspect ratio in the wrong spot. Right, width is 28, height is 15. Height is 15, width is 14. Width is 28, height is 15. 15, 15. So how in the hell did this change? Our position must have changed? Wait, why are we calculating this offset? We know this offset. It's probably, yeah, like why the hell is our position changing? Our offset's already built in here, isn't it? Like this downward angle thing is just shit. That's because our Z is changing. So we're, so how are we, all right. Yeah, something with our, our camera is actually doing something based on the width of the screen. It's moving it farther up based on the width of the screen. Is it the offset? Is there some sort of offset that we have on the camera? Because I guess we already have the camera width and height. The camera is moving up. Why is the camera moving up? You'd expect the camera... Can this... this fucking preview is just annoying. The reason the camera's moving up is because it's looking at more, so it has to be farther up. So we have to take into account the aspect ratio in some respect is changing the way this works. So we can take the current camera width and divide by aspect, and that'll give us our current camera height. Those things were identical at the 1 level. Let's see, is our Y changing based on our aspect ratio? No, just our Z. Alright, so the camera position, we're going to take the camera offset Z is 0.33 times the current camera height. Well, the other thing is we have to fix this. So this is not the absolute distance. The distance is going to be like that's the x distance, but we need also the y distance. So that's going to be the z distance difference.